Good morning, students. I hope you all are preparing your lessons regularly and keeping yourself updated. So far, we have studied the preparation of hydrogen gas in the laboratory, how to prepare hydrogen from cold water, from dilute acids, from alkalis, and industrial preparation of hydrogen by Bosch process. Today, we are going to start with properties of hydrogen. Let us begin with physical properties of hydrogen. In the lower classes, you have already studied that hydrogen gas is a colorless, odorless, and a tasteless gas. It is non-poisonous in nature. Hydrogen gas is one of the lightest gas known. As far as solubility is concerned, hydrogen gas is very, very slightly soluble in water. The boiling point, it boils at minus 250 degree Celsius, and the freezing point is minus 259.4 degree Celsius. Now, today we are going to discuss in detail how hydrogen is readily absorbed by certain metals at ordinary temperature. Keep in mind, keep in mind two metals like platinum, nickel mostly, and to a certain extent palladium also, as well as gold, they readily absorb large volumes of hydrogen on their surface. And this phenomenon is called occlusion. The word is occlusion, Occlusion. In simple English, it means the absorption of a substance from a gaseous medium by solids. Occlusions can occur if precipitation or crystallization occurs rapidly. Now let us discuss the chemical properties of hydrogen. First and foremost, combustibility. Whether hydrogen gas burns in air or not. Yes, pure hydrogen burns quietly in air with a pale blue flame forming water. In fact, it explodes. It gives a pop sound when it burns in air. Now, as far as supporter of combustion is concerned, it is not a supporter of combustion. It does not support combustion. This gas is neutral in nature, meaning it is neither acidic nor basic, or you can say alkaline. Now, we begin with reactions of hydrogen. How does hydrogen gas react with certain non-metals, for instance, oxygen, chlorine, nitrogen, sulfur, etc.? First, hydrogen gas, it burns silently in oxygen with a pale blue flame. It produces popping sound. So, the chemical reaction that is taking place is hydrogen burns in air, oxygen to give you water. So, the final product is what? Water. Similarly, chlorine and hydrogen react under diffused sunlight, not direct sunlight, remember, because if it is direct sunlight, then the reaction will be very, very explosive in nature. And the product formed is hydrogen chloride gas. Next is nitrogen. Now, nitrogen and hydrogen gas, it gives a reversible reaction to produce ammonia gas. But this reaction will take place only under specific conditions, optimum conditions. For instance, The optimum temperature is between 450 to 500 degree Celsius. The pressure has to be high so that nitrogen reacts with hydrogen. It is between 200 to 900 atmospheric pressure. And the catalyst chosen is finely divided iron. So the catalyst will accelerate the rate of reaction. And the promoter is molybdenum. Now, why did you choose a promoter in this case? This will check the poisoning of the catalyst. It will prevent it from poisoning. Otherwise, the efficiency of the catalyst will be reduced. And what is the final product formed? Ammonia gas. Next is sulfur. Sulfur, is a yellowish non-metal. Hydrogen gas, when bubbled through molten sulfur, what do you get? You get vapors of hydrogen sulfide gas. And you know very well that hydrogen sulfide gas has a smell of rotten eggs. Now let us discuss the reaction of hydrogen gas with potassium, sodium, and calcium. These metals are placed high above in the reactivity series, potassium being the most reactive, followed by sodium, followed by calcium. Now, potassium, sodium, and calcium, any one of these metals on heating, okay, it reacts with hydrogen to give you hydrides. So, potassium reacts with hydrogen to give you potassium hydride. Similarly, sodium on heating with hydrogen gas, it gives you sodium hydride. Then calcium and hydrogen, when you react, the product formed is calcium hydride. So the corresponding products will be metallic hydride, whether it is potassium, sodium, or calcium. The hydrides further react with water, forming hydrogen. Let's take an example. Calcium hydride, when reacted with water, will give you calcium hydroxide, and a colorless gas is given off, which is hydrogen gas. Hydrogen gas as a strong reducing agent. What does that mean? Hydrogen has a strong affinity for oxygen. It acts as a reducing agent. For instance, if you pass hydrogen gas over heated metallic oxides such as zinc oxide, ferric oxide, lead oxide, cupric oxide, hydrogen will reduce the metallic oxides to corresponding metals and and water is given off. For instance, if you heat cupric oxide and pass hydrogen gas over it, you'll see that the black mass of cupric oxide is changed into copper metal, which is reddish brown in color. Hydrogen is a very strong reducing agent. It can also reduce metallic oxides like ferric oxide, lead oxide to the corresponding metals. Now we move on to hydrogenation. What do you understand by the term hydrogenation? Hydrogenation means addition of hydrogen to organic compounds in the presence of a catalyst like platinum or nickel. For instance, if you take ethene gas, C2H4, when you react with hydrogen in presence of a catalyst at an optimum temperature, you get ethane gas. Similarly, if you pass hydrogen gas over ethine, then you get ethene gas. That is all about hydrogenation. Now, what do you understand by the term hydrogenation of vegetable oil? On passage of hydrogen through liquid vegetable oil in the presence of a catalyst at high temperatures, they form compounds which easily solidify or form semi-solids on cooling. This process is called hydrogenation of vegetable oils and it's used in the manufacture of vegetable ghee, soap, etc. We come to the end of today's lesson. I would request all of you to revise your lesson. At the same time, watch the video very closely and then you attempt the questions that's given in the assignment. Thank you.